Hi, Algebra 2. In lesson 14 here, we're going to be working with graphs that represent situations and to interpret what's going on in those graphs. Here we go. When you use your calculator to evaluate h of 0 and h of 0.8, you'll see that they both end up with the answer being 0. And what does that mean in terms of the frog's jump? Well, it's going to mean that these are the times at 0 and 0.8 seconds when he is on the ground. Number 2 is asking how much time after it jumped did the frog reach the maximum height. So we're not asking for his maximum height, but when did he reach that maximum height? So if he was on the ground at 0 seconds and at 0.8 seconds, his maximum height is going to be right in the middle at 0.4 seconds. Now we're going to go a little bit beyond this question. It's not asking us to find the maximum height, but we have all the information, so let's go ahead and do that. If we know that he reached the maximum height at 0.4 seconds, well, that's our t that we can plug back into our equation. So our original equation is written here, 60t minus 75t squared. And so now instead of t, we're just going to put in 0.4. And you'll see that we end up with an answer of 12. If you go back and look, the units we're using are inches. And so we know that at 0.4 seconds, he was 12 inches in the air. That was the maximum height. Here we know that the 2 is that number just by itself, no variable. So that's going to be the starting height from which the pumpkin was launched. And the negative 4.9 t squared. This is going to be the effect of gravity. Normally we've been seeing negative 16. That's when we're talking about feet per second. But this problem is dealing with different units. This problem is dealing with meters. And so 16 feet per second is 4.9 meters per second. The graph is going to open downward. If you think about what this is going to look like, it's because we have gravity. The pumpkin's going to go up and the pumpkin's going to go down. The vertical intercept right here is going to be at 0, 2 because we know that that is the y-intercept from the equation. As for the horizontal intercepts, one of them would be over here in the negatives, and that one's not going to make sense for us because that would be negative time. And the other one is going to be out here somewhere. We don't know the exact seconds, and we don't really have the calculations yet to determine that. We will get to that point later. When you graph this, make sure that you are comfortable changing your window so that you can actually see what your quadratic equation here should look like. And then remember, you can just tap on these important points and they will tell you the coordinates of those points. So here we have 0, 2, that's our y-intercept. We know that that is the height from which it was launched. We have the vertex up here at 2.418, that's how many seconds. And then 30.658, that is the height. And again, this is in meters. So that is going to be close to 100 feet tall. And then over here is going to be when the height is 0, so it's now on the ground after 4.92 seconds. In our next activity, we see the flight of 2 baseballs. The first one is from player A, and they're giving you a graph of that one right there. The second one is player B, and they are going to give you an equation for player B. So I wrote that equation over here. It's also in the problem right there. Now you're not going to graph player B. You're going to be comparing these using a graph and the equation. So first question, which player's baseball stayed in flight longer? I can see that player A's baseball hit the ground just shortly after 5 seconds. To figure out how long player B's baseball was in the air, we need to find the zeros because again, those are going to be our x-intercepts or when the ball hits the ground. And so from our first factor, we need to figure out what does t need to be to make this equal to 0 because anything times 0 is 0. So over here, I'm just going to write down my own little equation because this first factor isn't very easy to figure out just by looking at it. What does t need to be here to make it all equal to 0? So I wrote my own equation. I'm going to solve this just like any other equation. And we're going to see, sorry, this is getting messy here. I'm going to divide by negative 16. And I'll see that I get t to equal negative 1/16. So it would be negative 1/16 seconds, meaning that's when it was on the ground. And then the other 0 from right here, this one's a little bit easier. We see t equals 4, and that's going to be 4 seconds. So the baseball was on the ground at 4 seconds and at negative 1/16 seconds. This one, negative time, does not make sense in our problem. And so we'll just ignore that one. And so we know that the baseball was in the air for 4 seconds. This is the other 0 when it hit the ground. For player A, we can see from the graph that the maximum height is somewhere around 105 feet. And from ours, again, we had these zeros at negative 1/16 and 4. And we know that halfway between is going to be the x value of the vertex of that highest point. So to find halfway between, we need to do a little estimating here. Let's estimate negative 16th to be 0 because it is really close to 0. And then we have 4 over here. Halfway in between is going to be 2. So that means when time, not x, when time equals 2 seconds, that's when the baseball was its highest. Now what that height actually is, we can take that 2 and plug it in to our equation. For player B, when we plug in 2 seconds, that's when the ball is at its highest, we're going to get a height of 66 feet. Now comparing that to player A, even though we had to estimate that 2 seconds was the vertex, player A is clearly going to be much higher than player B. The height at which each baseball was hit, we know is going to be the y-intercept of your function. And so for player A, that's easy to see. It's right there at about maybe 5 feet in the air. And for player B, we would be able to find it after we multiply this out. When you multiply it out, I used a diagram right here. And when you simplify your like terms, you get this over here with 4 being the y-intercept. It's not asking here which player hit it from a higher height or anything. It's just making sure you know where to find that information from both the graph and the equation.